Good morning. Now, again, this is an important type. Sum number 3. Given an alternative, not given, it should be given alternative equivalent simple circuits for the following circuits. This is wrong. What is given? Given alternative equivalent simple circuits for the following circuits. Let me explain first. Second and third will be solving here. See, many students directly say that a symbolic form of the given circuit is, you won't get marks for that, because in the circuit you can see S1, S2, S1 dash. So how can you directly write P? So you have to begin with, let P stand for the switch S1 is closed, Q, the switch S2 is closed, so not P will stand. Now why to write not P? Because S1 dash is also given. So not P will stand for the switch is closed, or S1 dash is closed, or switch S1 is open. So what is the symbolic form? It is P and this is parallel combination, not P or Q. Now you have to simplify this using laws of logic. Now first distributive law. So P and not P, or P and Q. Now what is P and not P? It is always false. Reason, complement law. Now it is false or P and Q, P and Q. Because if P and Q is true, this is true. If P and Q is false, this is false. This means only two switches are to be connected in series. So the the alternative equivalent simple circuit is this. Okay. So this type is important from exam point of view. Now, second part, see, you have to begin with let P stand for switch S1 is closed, Q for switch S2 is closed, R switch S3 is closed, and so on. I have directly written the symbolic form is what? P and Q are R, or not R and not Q and not P. Now consider this. This is nothing but negation of R or Q. Reason, Morgan's law. Then next step, commutative law. I have written P first, and then here R or Q is same as Q or R. Same reason, commutative law. Now next step is important, distributive law. So this is P and Q or R, or negation of Q or R. Now what is Q or R or its negation? It is nothing but true. Reason, complement law. And what is P and T? It is P. Of course, I must write reason for this, identity law. Identity law. This means only one switch is required in the equivalent circuit. So this is the equivalent circuit. Question number 4. Write the symbolic form of the following switching circuits. Construct its switching table, that is input output table, and interpret it. Okay. First one, can you tell me the symbolic form? Of course, see, if you do not write this, write the initial part, you will not get full marks. In the circuit diagram, you can see S1, S2, S2 dash, etc. But we write PQR. In this case, PQ, not P, not Q. So first we have to mention, let P stand for switch S1 is closed, and so on. Here I am writing directly symbolic form. Yes, what will be the symbolic form? Symbolic form will be basically this is parallel combination. So just check this, P or not Q, or now I will have to write this in bracket because switches S1 dash and S2 are in series. So not P and Q. Just check this. Now input output table. Actually, in the first column also, I should have written 1100, second column 1010. In exam also, instead of T, you have to write 1, instead of F, you have to write 0. So you will notice that all entries in the last column is 1. Each entry is 1 rather. So the conclusion is current always flows irrespective of the position of the switches. So here I have written that lamp will always glow. So this is for the first part. Now second, what is the symbolic form? Symbolic form is P or not P and not Q, or P and Q. Yes. Now construct switching table. So this is the switching table. You will notice that entries in the last column are 1101. So lamp will not glow in only one case. Which case? S1 is off and S2 is on. Don't just say S1 is off, because when S2 is also off, current flows. So lamp will not glow only when S1 is off and S2 is on. Otherwise, it will glow. Now this is the third part. See, you have to write let P stand for the switch S1 is closed and so on. And then you have to write the symbolic form. Okay, this is the switching table. Observe that final column and the column of P are identical. Hence the lamp will glow when switch S1 is on. See, first and last entries in the first and last are identical. So if switch S1 is on, then only lamp will glow. This is the conclusion. Question 5. Obtain the simple logical expression of the following. Draw the corresponding switching circuit. The first one is playgroup. P or Q and not Q. See, Q and not Q is contradiction, fallacy. Reason complement law. Now it is P or F. It is P, identity law. So only one switch is required. So we say let P stand for switch S1 is closed. So this is the switching circuit. Now second, see, we are given not P and Q, or not P or not Q, or P and not Q. Now this step is important. Consider first two. I can write this as not P and Q or not Q. Reason, distributive law. See the cursor. Okay, we'll increase this size. Okay, distributive law. Now Q or not Q is true. Complement law. What is not P and true? Not P, identity law. This as it is. Again, distributive law. Not P or not P and not P or P and not P and not Q. Distributive law. But not P or P is always true. Complement law. True and this is nothing but this only. So not P or not Q, identity law. You may also say this is basically negation of P and Q. Yes, but why to write that? So the simple logical expression of the given expression is not P or not Q. So let P stand for switch S1 is closed, Q switch S2 is closed. So not P, switch S1 dash is closed or switch S1 is open. Same thing. Same for not Q. So the given switching circuit reduces to this one. Okay. Fourth one. See, P and Q and not P. In the first step, using commutative law, I have written P and not P. Basically, this is conjunction and P and not Q is false. So false and Q is false only. But the only thing is we have to write this in two steps. Okay. So commutative law, then P and not P is false. That is complement law. False and Q is false. That is identity law. But in the same step, see, I have put these two in bracket. Now in both Q and R is present. Here not P, here P. So by distributive law, I can write this as not P or P and Q and R. But again, what is not P or P? Not P or P is always true. Actually, I have omitted one step. False or this is this. But here, what is not P or P? It is nothing but true. Reason complement law. Now, what is true and Q and R? It is simply Q and R. Reason identity law. This means only two switches are required. Right. So this is the simplified expression. Now we say that let Q stand for switch S2 is closed, R stand for switch S3 is closed. You may say S1 and S2 instead of S2 and S3, but generally when PQR are given, we denote them by S1, S2, S3. So these two switches are in series. So this is the switching circuit. Now, miscellaneous exercise, select and write the correct answer from the given alternatives in each of the following questions. First one, P and Q is false and P or Q is true. Then which of the following is not true? See, P and Q should be false at the same time. P or Q should be true. So these two combinations only. Now options, P or Q. It is true. P biconditional Q is false. So B seems to be the correct one. If you check C and D, actually for D, for one combination it is true, for other it is false. But for both it is not false. That is not true. So we say that B is the correct option for first one. Second, P and Q implies R is logically equivalent to. See, if you observe options, B cannot be the correct option because it is P and Q implies not R. Okay. But D cannot be the correct option because P or Q implies R. Now, what is option C? It is not P or not Q implies not R. Basically, what is not P or not Q? It is negation of P and Q. So, P and Q implies R. How can it be logically equivalent to not P and Q implies not R? So A seems to be the correct option. P implies Q implies R. Actually, you have to check this by constructing truth table. So A seems to be the correct option for sum number 2. Now, sum number 3, inverse of the statement is. So what is that inverse? It is not P and Q implies not P or Q. But what is negation of conjunction? So it is not P or not Q implies not P and not Q. See? Oh, this is contrapositive, right? I have written contrapositive. We are asked inverse. Just a minute. This is contrapositive. We have to find inverse. Okay. This is contra, which is not asked. Sorry. So it is what? Negation P or Q implies negation P and Q. So this is not P and not Q implies not P or not Q. So correct option for sum number 3 is C. I repeat, this is contrapositive, which is not asked. So for the third sum, correct option is C, Calcutta. Don't write this. This is contrapositive. Now P and Q is false. P implies Q is false. See, P implies Q is false in only one case, when truth is implying false. Okay. Just check whether P and Q is false for this. Yes. Then the truth values of P and Q are P, F. So correct option is B, Bombay for sum number 4. Just check this. See, that is why you should remember the table. This is for fourth one. Actually, in the textbook for sum number 5, C option should have been P or Q. Correct that. Not only that, the sums is negation of inverse of not P implies Q. Just a minute. Please write down this. See, what is inverse of not P implies Q? Inverse of not P implies Q is not P implies not Q. That is P implies not Q. Okay. Therefore, it's negation. So not P implies not Q is P and not Q. That is P and Q, which is nothing but Q and P, commutative law, which is given in option A. Now this is the correct one. Please make this correction in sum number 5. And in the textbook, C option should have been P or Q. So that correct option is A, Ahmedabad. Sum number 6, the negation of P and Q implies R. Basically, it is negation of conjunction, which is disjunction of negations. Now, what is negation of Q implies R? It is Q and not R. So this is given in option D. Let me explain 7th also. Set A is 1, 2, 3, 4, 5. Then which of the following is not true? Option A. There exists at least one x in A such that x plus 3 equal to 8. Yes, 5 plus 3 is 8. So A is true. B. At least for one x, x plus 2 less than 9. Yes, 1 plus 2 is less than 9. So B is true. C. Usually universal quantifier, if it is used, it is usually false. Not necessarily, but in most of the cases. So for C, for all x belonging to A, x plus 6 is always greater than or equal to 9. No. 1 plus 6, 7. 7 is not greater than 9. So statement given in option C is not true. So correct answer is C. Second question, which of the following sentences are statements in logic? Justify. Write down the truth value of the statement. First one, 4 factorial is 24. Now it is a statement which is true. 4 factorial is 1 into 2 into 3 into 4, 24. I will just write T. In exam, you have to say that it is a statement which is true, hence its truth value is T. Second, pi is an irrational number. Yes, it is a statement which is true. So truth value is T. Third one, India is a country and Himalayas is a river. Okay. It is a statement. Basically, it consists of two parts, and this is conjunction. India is a country, true. Himalayas is a river, false. True and false is false. So true and false, therefore false for third one. Fourth, please get me a glass of water. Imperative. We have to say that it is imperative. So it is not a statement. So obviously no truth value. Fifth one. Cos square theta minus sin square theta is cos 2 theta for all theta belonging to R. Yes, it is a statement which is true. So T. Last one. If x is a whole number, then x plus 6 equal to 0. False. X will be minus 6. Minus 6 is not a whole number. So truth value is F. So that's it for today.